Okay, let's get started. Now that I'm finally organized. What are we going to do today? We're going to go through about 4 projects, and we're going to build them from scratch, and I'm going to go as slow as possible. And they all have a purpose to them, showing different features of Xcode and showing different features of the project implementation. Because I know you guys don't like listening to PowerPoints, because I seriously can't stand giving you PowerPoints either. So what we're going to do today is more hands-on, so I see a lot of you brought your computers, which is really good. I uploaded these projects and I made them from scratch, so I'm not sure if well, this will be fun. I'm not sure if my steps are exactly the way they're supposed to be. So, because I did them in a hurry. So this will be a proof of concept as well. So if you go into the iPhone application development link, because I know you're going to want to download these projects, and if you go down to the bottom, if you go into lectures, it's in the lectures link. Probably should have put them in examples, but I made these in the form of lectures, so they're PowerPoints. I'm not giving you the completed projects, and I'm not going to bring up the completed projects, although I have sampled them out while trying to build the PowerPoints for them. So I'm hoping I'm going to be successful at all of these, but we'll see. They're pretty simple. But here are the PowerPoints that correlate to it. So we're going to be looking at a UIAlertView, which is an alerts window that comes up. We're going to be building a program that takes a string and converts it to a number, and then vice versa. So just to look at the numbering and things of that nature. We're going to take and reverse a string, and this one's going to be using a prototype, as we saw. So if you're not taking the iPhone class and you want to know about protocols, which is what we just covered, this one's going to be using a protocol interface. And then converting temperatures is going to use a lot of stuff. It's going to use functionality with buttons with UI components. So it's all putting the pieces together. I figured these are kind of the beginning, a little bit past Hello World, a little bit past what we've seen so far. So it's putting all the pieces together, hopefully. And I figured the more apps we build as a group, the easier things will come for everybody, I hope. And in the meantime, I'm going to be, hopefully, as I remember, explaining Objective-C programming techniques and stuff like that as well. So I'll see how this works out. The first one is going to be called the UIAlertView. And I put this in a window here so I could run through, and the mouse is working. Okay, very good. So I can run through both the PowerPoint and the Xcode simultaneously without having to shut the PowerPoint down, because otherwise this goes into full screen mode. So what's a UIAlertView? Well, we've always seen those alerts in regular old MFC programming, or even in Java. We can send up an alert, or even JavaScript actually has alert boxes. These are lightweight little boxes that show up out of nowhere that show us information. So we're going to program one of these. And we're going to do a little color changing experiment to change the background color of the window. So the user will be able to select between different options. And we'll see how to put up one of these little windows and then see how to make it work. So it allows you to present a similar interface to an alert that the user has something inside of it, to alert the user about something that's happened. And it also allows you to respond to different ways depending upon the buttons. So we'll see a case switch kind of structure used to kind of go between the different buttons. If we want more than a default cancel button on an alert, we have to adopt what's called a UIAlertView delegate protocol. So I believe that I covered protocols in this class, as most of you probably slept through it because it was a boring PowerPoint. Think of a protocol sort of like an interface. If you were just in the Objective-C class, I just covered it, but think of it sort of like an interface, and I'll show you how that works. That basically decides, we have built-in protocols that have built-in functionality, which are methods that are given to us that we can just adopt the protocol in our class implementation and use the functionality, is essentially what we're going to do. So, step number 1, for those of you who have a computer, I highly encourage you to step along with this and build the project along with me. Perhaps you can show me where I'm going wrong as I'm building the project. Who knows what's going to happen here. But, of course, your typing is probably going to be better than mine. So start Xcode. Create a new Xcode project. Select a single view application template and then click on Next. We're going to use the auto reference counting feature. And we're only going to do a single And I'm not gonna bother with the storyboard for any of these examples today. So it's going to be using a single view. So we're going to use a single XIB. So I'm not going to select the storyboard option. So I'm going to bring up Xcode. And I actually discovered something kind of nifty. I can get rid of all this stuff here. This is kind of interesting. If I go into Open, Recent, and then Clear Menu, when I open up Xcode, it's empty. Nice. Because I'm like a clutter freak. So I delete stuff off everything all the time, and I load stuff up. So I just discovered that. So I'm sure it was on there for years in the previous versions and stuff. So I just select create a new project. I'm going to click on a single view application. Clicking on next. Which one is this? This is going to be called, I'm going to call this color example. It's really not very representative of what it is. I can call it color selector. Let's call that color selector, because we're going to switch between different colors of the background with a menu. So use automatic reference counting. I'm just going to go with the flow today and just use, I don't want to talk about memory today. So we're going to have the Xcode do it for us. But don't select the use storyboards, because we're going to have single view. For most single view applications, I wouldn't use a storyboard, seriously. It's just one single view, one XIB window. Why complicate things? So next. And I'm just going to save it on my desktop. You can put it anywhere you want. So I'm clicking on Create. And hopefully I have it up here. You can see I've got the, the basics here. Now I kind of learned something else too recently. For some strange reason, and maybe you can tell me, maybe somebody has the answer to this one, but why does it always say iPad when I do? I always have to switch it to iPhone. I should be able to switch my default, I think, somewhere, but I haven't spent enough time looking for the answer to that one. So I'm going to put it on iPad, because I know I have two XIBs here. I've got one for iPad and one for iPhone, because I selected the project type as universal. I guess I could fix that problem by selecting the project type as iPhone, but I didn't. I was too quick going through that. So I'm going to use the iPhone XIB. If I click on the iPhone XIB, I see the nice little window over here. So now I'm going to go back to my PowerPoint. I accomplished step number 1. Very good. In the XIB file, because I always start with the GUI first. Okay, I'm going to add a button to the user interface that will bring up an alert window, alert view when pressed. I'm going to open up the library and I'm going to drag a UI button to the view. I'm going to change the title of the button to change color. And if desired, change the view's background color as well. When you're done, the interface should look like this. There we go. So I got a button. So I kind of like this style. I'm going to do all my tutorials like this now. So let's see what it's supposed to look like, so I can remember what it's supposed to look like. Okay, so I'm going to click on the XIB, and if I go over here to the right-hand side, I see this is where I can actually change the background. So I'm going to actually change, I'm going to click on green. I like this green color. So I'm going to, and I go, oh, nothing happened. Well, you click on it, it updates itself automatically. So now I got a green background. So if I wanted to, I can change the fonts. I can change a bunch of different characteristics about it. It's going to be in this one here. This is going to be called the Attribute Inspector. It's the 1, 2, 3, fourth icon over, actually. And then because I have the window selected, I'm able to change the attributes on the window. So I'm going to drag one of these rectangles. It happens to be the first item in my list here. If it's not, you can click on the bottom here on the search window and type in button. And you see the rounded rectangular button show up. It's the same one we've actually been using in a couple of examples. So I'm going to grab it, put it on here, and I'm going to put change color. Oh, I didn't capitalize the C, did I? Yeah. Okay. Change color. There we go. That looks pretty cool. So hopefully you've made it this far and I'm going slow enough. So it says change color. I didn't put the 2 dots next to it, but that's okay. Right, now what do I want to do? I want to figure out why my mouse is broken. There we go. Now I'm going to click on the editor tuxedo on the right hand side. This is a second item in here. This is going to be the show the assistant editor. And the assistant editor brings up my code in the 2 panes window. So I'm going to call this, for the rest of this course, I'm going to call it the tuxedo icon. It's the second one in. So you're going to right mouse click and select touchdown on the action control for the button and drag it to the .h file. Label the button touch. The code looks like this. Okay, so I want to put this code, essentially. I'm not going to cut and paste it. I'm going to create it in the project. How am I going to do that? Well, I'm going to take, I only have one item on this screen, and I wish, oh, I can. I wish and it worked. There we go. Here's my little screen. If I click on it, and if I press Control and I drag, I'm not going to get very much of what I want. Because this is a button, and I can do that for other items, but instead I'm going to run a right mouse click, and I'm going to have this whole selection of options that I can pick. And one of the options I can pick are color going to be touchdown. I think I wanted touchdown right here. So I'm going to press this button and press down, excuse me, click on the plus that's next to it, hold down the control, and then drag it in. I have to put it in between the interface, at interface, and the at end. So if I let go, what did I want to call this? Button something? Let's see. Button action, BTN action, or button touch. I think I called it touch. It doesn't matter. I can always change the name. Button touch. Press OK or cancel. Excuse me. So then now I can close this little window. Differences between that and a label. Let me just put a, well, if I put a label out here, I can actually change the attributes. We're going to do that today with a label. We're going to have a label that responds to entering in stuff as well. So just to reiterate, what I created was called an IB action. And if I put my mouse over, hover it over, I see it's going to be on the change color button. And I can see that change color light up. And I can see over here, touchdown, the UI button, sender. Well, it says ID over here. Well, this is the generic. Okay, so here's an interesting thing. I'm going to actually change the code. Actually, I'm going to leave it alone and see what happens. At the end, I can always change the code and put it back. What we're looking at here is called a data type. The data type is generic in this particular case because I didn't specify this was a button. I didn't drag the button over. I didn't identify it. I am in the controller.h. Phew, good. I need to be in the viewcontroller.h file when I'm doing this. This is the data type, so I'm not really saying that it's a button. In the example here, I can actually change it to UI button with this pointer here at the end, which means every object that's a UI object, a UI button, an NS string, all those things are pointers to objects. We don't require a pointer for ID because it's a generic object type. I'm going to leave it alone, and I'm going to think in the future, let's see if it works actually. I can't remember. This was done in, this was actually just, just kind of the generical. So I'm going to know that, okay, I can probably change my data type in the future, but let's just leave it alone. Over here, I'm going to switch the view to UIController.m. If I do that, I'm going to see an entry down here on the bottom. This is where my button touch is down here on the bottom, if you can see that. Way down here on the bottom of the screen. And this also says ID, so I know if I change it here, I'm going to have to change it back up here eventually as well. But I'm just going to make note that, it's a little bit different. So let's see if it works. Might not, actually. It might have to be a UI button, actually, because it's a UI action, IB action on a UI button as the data type. But let's see. So in the viewcontroller.m file, we have, you know what? I'm going to switch it to UI button. I've decided I'm going to switch it. So go ahead and switch yours. Type in, you can always experiment it later. I just want to make sure this works. So type in UI button here, and then put an asterisk in because it's a pointer to a UI button. Change it in the .h file if you're going to change it. Some of you can leave it alone if you want. We'll see it. We'll have an experiment to see if it has an effect. It's just the data type. So I changed it here. And if I go back to the .m file, I'm going to notice that it's not changed. It only gets populated when I originally drag it. It gets copied to both. So I'm going to have to change it here too. So I'm going to type in UI button. And no, on this one there is a pointer actually. And this is the .m code that we're going to type in. I hate doing this, but let's just make this one here go this way so you can see the code. Make this go this way. I don't want to get rid of the screen because I might want to go back to it. There we go. So as I'm typing in the code, I'm going to kind of tell you what the code's about. See how successful this is. So this is a bit word wrapped. I can make the screen a little bit bigger. It's not going to go this way, is it? Okay. So this is the method body implementation for the method that we just created in the interface, because we're in the .m file. Make sure you're in the .m file. What you're going to do is, the method body was already created for us in the bottom here. So I made it match the method here, and it's the sender on the IB action, which means when an action occurs, take the action in as a parameter that's coming in from the UI button as the object, and perform this. So what I'm going to do is I'm going to create a new instance of this UI alert view. So I'm going to type in UI alert, and I'm going to use this return key to automate things. And I'm making the new instance, I'm going to call it color alert. Color alert. And it's going to be equal to, now see this, I wish I could make, here I'll go like this with it. There we go, bring it up a little bit. Ah, there we go, that's a little bit better. Brought it up a little higher off the bottom of the screen there. So, color alert, let's see. Color alert, and that's going to be equal to a new UI alert view. You can press the return key to kind of automate things, alloc. And then I'm going to end the the brackets. And then there's a second part of it, which is initialize with title. So let me, the reason why I kind of am trying to do this is I'm trying to explain the code to you as well. So we know that when we want to create a new instance of an object, we have to allocate it. So alloc, and this is just the first part of the statement. I'm going to have this red thing because the statement's not complete yet. Alloc is basically saying allocate a new UI alert window. Well, your new UI alert window is kind of like a UI button, or it's a pre-existing object. It's an alert window. We're going to make a new instance of this alert window. The initializer, which is sort of like a constructor for the alert window, we can run the initializer when we create the new instance, which is what we're doing here. We're allocating and initializing. So in other examples, you might see this actually, where we're running init. And init would just be a generic initializer for the object. But in this particular case, we're not running just the plain init. Instead, we're going to initialize with, well, let's give it a title. Let's put a message in the window. And let's create a new instance of delegate, which is what we're going to need. And then put a cancel button on there for none, and other buttons. We'll put some other buttons on the window as well. So I'm going to type this in and then I'll run it. You can actually kind of see what it does. Or I could be lazy and try and cut and paste it, but let's see, I'll just... Alright, let me just practice my typing. Alright, it's not going to take that long. So init with... Oh, see, this is the problem. I can't type. Init with title. If I just press return, though, I don't have to type. At so what am I going to do? At change color. See, there's more satisfaction in the end result when you type it. Message, colon. And what's the message going to be? Change color, or choose color. We'll see how the message shows up on the screen actually. Choose a color. And then we're going to have delegate, delegate self, delegate colon self. Okay. That didn't last very long. I'm going to cut and paste it. I know. This is... I don't have any patience, I'm sorry. You can cut and paste it too if you download the lecture. So. This is the, yeah, this is the one that's called the UIAlertView. There's 4 of them. Actually, now that people are... Hold on a second, let me just paste here. I already have that line. There we go. Because I have a bullet point now in here. Well, cutting and pasting didn't quite work either. Now let's see what the message is going to tell me. Expected identifier. Oh, let's see. Let's just do this. Let's see. Oh, that's because I have bullets here. Get rid of these bullets. Okay, so cutting and pasting has its pros and cons as well. I have another bullet here. When I cut and pasted it, I have the bullet points that showed up here. There we go. Now everything's gone. So those of you at home who are as lazy as I am, or those of you sitting out here who are as lazy as I am, you may find these examples at lectures. So what I done, I went into the iPhone application development link for this particular course, and I'm clicking on lectures, and it's these 4 lectures here. I'm doing the first one right now. If you cut and paste from the PowerPoint, remember that you'll have the bullet points you'll have to pull out, which I just did a few minutes ago. So in this particular case, now I have a kind of an oddly shaped screen. Hold on, let me get a little bit bigger. Let's see, make this one a little bit bigger. So now I have the event for the particular button. So if I run it right now, it should at least pull up the window. Build successful, that's always a good thing. And you know what? You get the same satisfaction out of it when you cut and paste and you put it in the window than if you type it yourself. As before I was saying, oh, maybe there's more personal satisfaction in the accomplishment when you write the code yourself. I don't think so. I don't think so. Oops, I've got a message here. Great. Let's see. Let me fix this real quick, actually. I accidentally removed something else I shouldn't have removed, so I'm just going to rebuild it again real quick here. It's easier for me just to build it again. Oh, color test. Let's call this one color test. Color play. I have the project saved, I believe, as well. So if I get real desperate, I'll just open up my completed project. It's extremely pathetic. Okay, so let's see. I can recreate these steps real easily. 2 seconds. Okay. Color. What do they call color chooser? Color changer. Color changer. Maybe type was UI button, which is kind of weird. Okay. Button something touch. Oh, sorry. I didn't do the IB outlet on the button. I didn't do the right one. Let's just do it this way. Button down. Ah, here's where I should have changed it to ID button. All right, So what I didn't do the first time was change the ID correctly. Actually, that's why I had to. Well, you seen I did it manually though, but it's probably better to select it from here. So I'm gonna go. You don't have to do that first property that I just put in, although I did it anyway. This one I'm gonna call button touch me, so I know the difference here. This is a UI action. As you've seen before, I actually did it twice. I only really needed to do it once for the UI action. But if you want, I can actually do it as an outlet as well. So I have the IB outlet that's on here as well, but I really want the IB action. I'm not really going to do anything with the outlet, but I'm going to leave it alone. So I'm going to switch over now and hopefully type this in without any typos. So if I go to the touch me, which is the item down here that I want, I'm going to now, where did our text file go? Cut and paste it in. I actually accidentally deleted like half the end of that file or something, I think. So I'm going to put this in here now. And hopefully this is a text format. Let's see. Oops, what did I do here? I have the IB sender. There it is. I have this in here twice. Just need it in here once. Get rid of this. And you know what? I still have my bullet points. Alright, so it's probably better to put it into a text file, or at least put it into a file without a PowerPoint without bullets for next time. Oh, shoot. Okay. Jesus. I'm like the world's worst typist, by the way, if you haven't noticed. Let's see. I am just pressed run on the project, and now if I, oh good, okay, now if I press color selector, I'm gonna get the well-awaited. This is like, I guess it's good because it's giving you time to retype in a couple of times as well. You'll get the dialogue. However, nothing happens when you press the dialogue. So I can select blue, I can select none, but I only have half the functionality implemented. I only have the button action on the selecting, so I'm going to head and close it. It's also not a bad idea to check it at certain points without getting too far. And I'm going to go back to these trusty slides. I believe this is... Alright, so the title will appear at the top of the alert, which we saw. I probably should have left that up. So we set the title by setting the message just on the init. And the buttons and the other button titles appear, and then we followed by the cancel button title. And so now the delegate parameters are defined in the object. It will handle the touches with self, meaning the view controller. So we don't actually have to do this, but we can wire this method to the change control after the fact. If we had cut and pasted it and put it into the code, we could then go from the code and wire it back. But I like to do things in the opposite direction, so I like to take this thing and wire it. It's called wiring. Take this item and wire it to the code initially before writing the code. But the instructions actually have you do it backwards. So we tested the app, as you just saw a few minutes ago. So we run it, we'll see the alerts. And you can run through these instructions on your own as well, slower pace. So in order to handle the touches on the alert buttons, we need to implement one or more of the delegate methods of the UI view delegate. So we have void alert view, alert view, alert view. Clicked button at index is what we're going to implement with an NS integer, which is going to be the button index. So the first parameter of the method will be the alert window in which the button is attached, and the second one is going to be the index of the touched button. So when we capture the events on the window, we're going to have the button actually, change the color. And here is our code for that, and I'm going to cut and paste. So now I'll say number 11. So slide number 11, cut and paste. And I'm just going to have to edit it when I put it in there. Although I don't see any bullets on this one, so this might actually go in. What we're doing is we're going to modify control viewer.m, which is the one that we had up from the last. This is control viewer.m. We can always tell actually from the color, called the color play, from the notes on the top. And we can stick this almost anywhere we want. I'm actually going to kind of stick it towards the bottom where I put the button here. It's not really related to anything at all. So I'm going to paste it. So we're not going to actually have to connect it because it's working with the UI, excuse me, the controller. So I have to actually kind of get rid of the dots here. Make this a little bit bigger at the same time. So the code for it, as I'm getting rid of the dots, I can sort of explain it. So the alert view is taking on the alert view with the UI alert view that we created as the location. On the checked button at index, it's going to look to see, well, what index, this is the event-driven part of it. It's actually written for us. We're just implementing the method to override it to say, well, when the button is clicked, give me which index it is. So switch the button index so that we have, get rid of this. These were spaces that ended up becoming, there we go. So if the self.view.background is equal to UI color red, then break, make it equal to red. I'm sorry, send red to it. Else, if it's number 2, which is our color selection number 2, which was for yellow. Oh man, why are we indenting like this? Okay, I'm just gonna bring it back this way. That's why. Get rid of that dot. Else, if it's yellow, which means it's number 2. I probably could have just typed this in faster. Just like this. There we go. Change the UI color to yellow. So we know that this is the UI color data member that we're sending the UI color, meaning set color for UI color, to yellow color, which are preset red color, yellow color, are preset conditions. Break. I don't know what's going on here. I have like an auto indenting that's messing me up right now, so let me just put this back. There we go. Case 3. It's blue. If it's blue, set the UI color to black to color blue. Probably could have typed it faster. Let's break. And then let me just, let's see. Or set the default. Break. Take out the comments because apparently I have special characters in here when I cut and pasted it. So. Okay, if you have successfully cut and pasted and gotten rid of all the special characters and bullet points and things you can't see that totally messed up my format, you'll have something that looks like this. What this is basically trying to do is go through a case switch. This is standard C programming. For C programmers will appreciate this. Objective-C is written from C, so this is the same notation. So switch the button index, case 1, 2, 3. What we're going to do is if it's on 1, set it to red. If it's on 2. And what we're doing is going view.background color, and then the color is going to be equal to set the UI color, which is the UI color for the view. We originally set the UI color over here when we set background. This is pretty much doing the same thing as calling to the object and sending the parameter yellow color, which is a built-in predefined color from that palette I just showed you actually with the green. Set UI color to that, or to blue, or to red. So if we run it, we should see, hopefully, the color actually selecting on the event when it occurs. So now we have color changer. I click on color changer, and if I go red, it changes to red. Yellow changes to yellow. I guess I can go through all that blue. So what we're doing essentially, actually go none, we're still on blue. So the code is essentially looking at the alert window, taking the alert window event that has occurred, and a clicked button at index is the method of the event on this window. So we have a bunch of built-in indexes. Nobody ever memorizes them all. You just look them up and say, well, if it's an alert window, then give me the click button index, and what is the NS? And we're using an NS integer as the data type. So it's a built-in object for the integer value for the buttons, and that's being set with just the integer value of button 1, 2, 3, 4 in terms of the order that we put the buttons on there. So this is kind of a give or take the random order that we put them on. So if we change the order of the buttons, we would get different order actually in terms of the action that we were getting. So if we change the colors around, we'd have to change it here to match the order that we put them in here. But it's just basically taking the raw order of the buttons and implementing it. So let's just see if this worked here. That's on number 11. So let's see, finish this up a little bit. I believe I was done with this project, but I'm going to take a quick look here. So we modified the view controller and we added the alert view to give us the breaks, and that's why it was bolded. The breaks were bolded in the slide. That's why it wasn't pasting correctly. So now we know to put it all in text format. You don't bold or highlight or bullet or anything. Okay, so the button behavior, the button index will be 0 if the cancel button is pressed and incremented values starting with 1 for the other button titles in the array, because this is an array that was created. So the array indexes, the null is the last one, which is going to be the nothing. So in this case, we've just changed it. We're just changing the color of the UI view. This is the program output, which is what we received. So on each one of the examples, I've also given you the program output as well, at the pretty much the last. So the summary is the UI alert view is the model view, meaning that it blocks, touches events from bubbling up to the parent view. So basically the UI view is capturing and it's going to block it from the parent. So only that UI view is going to show up when you click on that button because it's attached to the button press, the button touch. It doesn't hang the UI thread, which makes it very good control for simple choices because it's working simultaneously along with the other thread that's running. So did you all get your buttons to work? Oh, you got it to work? Okay, good. So you probably have learned from my mistakes in terms of the cutting and pasting. So I'm going to end it, unless we have questions, I'm going to end this one. And the next one's different. The next one doesn't have as much cutting and pasting, which is good. Yes?
I just did copy the case and paste it 3 times.
Paste it 3 times?
Yeah, just change the color.
Oh, yeah, that's true. Oh, yeah, you could do it that way. Or you could be lazy like me and just try to do the whole thing. But, you know, unfortunately, I should take out. I even tried to put it in here to get rid of it, but then I realized that this didn't work either. So I should just, I should seriously just install later. Seriously, just practice my typing. All right, so item number 2, converting strings to numbers. This one I will type in because this is going to be a bear. I'm trying to, not as much typing though. So on this particular project, open up a new expert project and we'll start fresh, same as before. But first, why are we going to convert? Everything comes in as a string. So the UI elements, the text field is an NS string by default. So if you're going to build a program that's going to take in information from the UI, like numbers, it's going to essentially give you strings. And so there's a conversion that you're going to have to go through. So this program is converting. So the program is going to essentially need to take input from the user. Usually comes through the form of a text box through an NS string type. The input is numeric, so you'll need to convert the string to a numeric type before working with it. So same as before, we'll go ahead and create, and I'll call this one, what's this in the background? Oh, it's my, create a new Xcode project. And this project is going to be a single view application. Click on next. Same as before, don't use storyboard, but use automatic reference counting because we don't have to deal with memory at this point then. This one's going to be called convert string to number, or anything you want to call it, actually. Next. And pick a location and click on Create. And I've started off on a good track and I have a working program. And I can see that I have all the support files that I normally need. I'm going to go ahead and click on the iPhone XIB and change the simulator over to the iPhone simulator, because I still at this point have not changed from the generic use all of the project types instead of just the iPhone. So create a UI that looks like this. We're going to have first number, second number, and we're going to add them together, and we're going to put the sum on the third UI. So we have 1, 2, 3, 4 labels and 2 text boxes and a button. So I can do that. Let's go ahead and build that. So first thing I'm going to do is play around with my background here. I'm going to actually make my background a pink color. There we go. I got a pink background now. It makes it a little bit more interesting. And I'll even put this out this way so I can sort of see the top part. Actually, that's not going to work. Let me make it. See, even with that other window there, it becomes well, I'll remember. Okay, first number, second number. So I'm going to drag over here. Make this bigger again. I'll just go back and forth. Alright, so these are going to be labels. So I'm going to have one label here. I'm going to call this one first number. And I'm going to put another label on here and call this one second number. Yeah, use the same convention as before. Second number. Then what else I got on here? Sum and label. So sum down here on the bottom. Sum. And then we'll put another label down here. I just left it as label because we're going to change the label. The label is going to show the sum of the two numbers that we put in together. So you can just leave it actually. Then I'm going to put my text boxes, and if I just scroll down here, I'm going to see the text boxes show up. I can search on this text box if I don't see it. Text box number 1, text box number 2. Unlike the Android environment, we don't actually have to worry about labeling them out here, which is kind of interesting. We just drag, we're going to control drag them to the .h file, and then we're going to see that they just label automatically. So clean up your UI. Move this over a little bit, make this more beautiful looking. There we go. Oh, I need to put a button in here too, so I'm going to round rectangular button here. And the round rectangular button is going to say add on it, so add. There you go. Alright, well, I came close. Looks like that. Oh, mine's a little bit different in colors. Hopefully everybody's close to that. If not, you can still work on it. People want more time? It's okay? Okay. Good, good. Well, I'll probably have to do it again anyway. Batting 1,000 tonight. I usually have to do the interface twice for every time you guys do it. Gives you time. Program behavior. Okay, so when the user touches one of the 2 text fields, you'll see a keyboard pop up. So we didn't do anything for getting rid of the keyboard, so make sure your stuff's at the top of the screen, because well, actually, if we run it right now, we can sort of test it. Actually, I'm moving my stuff up on purpose because I want to make sure the keyboard fits nicely underneath. So I'm going to go ahead and run it to show you what I'm talking about. This is automatic behavior you get. We haven't done anything but put a couple of text boxes out there. So we're automatically going to get the keyboard that pops up. We can change the keyboard behavior actually by giving it a return value. So if I click in here, my keyboard popped up. Keyboard's not going to go away. Well, actually, it'll go away if I go like that, but the whole app went away. So, but long story short, you want the stuff to go above your keyboard unless you want to program the information for what happens to make the keyboard go down. What you would do is essentially on a return, you would change down in here the return key, put it on done, and then put an action down there. And I'll do that in another lecture, actually. I won't do it today, but I'll do it in a different one. In fact, we have one coming up that'll take a look at that. And then we just basically make the keyboard go away to get rid of the keyboard on a done on the return type here. So all we do here is just change it to done. I'm going to leave it on default though right now just to make things simple. Okay, so when the user touches it, text keyboard comes up automatically. As they enter the text into the field properties can be updated with an NS string type. So you can read the values of the string by looking at the properties. But if you want to add the values together, you have to convert them, which is the purpose of this exercise. So the add button, through its IB action method, will do the work of converting the two NS strings from the UI text into the floating point numbers. So it will then add the two numbers. We're going to make a float out of this actually from the strings. But in order to display the sum in the last UI button, it will have to be converted back to the sum to a string. So we take it, the two strings that we're going to get from box number A and box number B, convert them to floats, add them together, and then take the float value to convert it to a string and put it back over here. This is going to be the sum. Doesn't sound too hard. So click on the editor or the tuxedo icon in the far right hand corner, which is this guy right here, and here's where the typing comes into place. Actually, this is going to be our dragging and dropping first. So then I usually move the window open so I can kind of see all the items here along with this window over here. So control drag the items to the UI view controller.h. So the code will look like this. So we have text number 1, this is a text field for number 1, text field for number 2, and then we're going to have the label sum. So I'm going to do the labels first. I'm just kind of systematic this way. So I'm going to grab text 1, text 2, and the sum. So I'm going to take this one, hold down the control key, and I'm going to drag it in between the interface and the end, and I'm going to let go. And I'm going to keep this one as a UI text. So I see in here, this is going to be a UI text field. UI text, IB outlet UI text field. So I've got IB outlet, and I'm going to call this one sum num1. And let me see, make sure it matches this one here. And I see that well, we've got strong and weak. I don't know if that's really going to matter, however. Number 1, okay, good. I'm just going to leave it. Actually, we'll just see what happens. Control, drag it down here. I'm going to call this one num2. And it is of a UI text field type. Very good. And then this one's going to be here, the sum. So I'm going to control, drag it down here, and call this one the sum. And oh, here's where I could check. You know what? Well, I was supposed to make them strong. Alright, so this one I actually did correctly. So they're supposed to be strong, so I'm actually just going to see if this works here. I'm just going to go over here and go strong. Change them to strong. I didn't change it in the toggle box again, but I could have, but I didn't. If I would just follow my own instructions, I'd be much better off. Okay, so I'm going to add the touch, button touch. So add a button touch. So on the button here, I'm going to right mouse click. And yeah, this little screen actually moves out of the way too, because some people it comes in over here. So you can move it over here if you want to. On the button touch down, I'm going to control mouse click and put it down here underneath. Let me make sure I get this one correct. It's supposed to be a UI button. Okay, good. So I'm going to select, so under ID UI button. Okay. And what am I going to call this guy here? I'm going to call it add button. I'm going to call it add button, actually, because I'm kind of lazy. Add button. Well, okay, I'll call it add button touched. And I did it for the touchdown event, actually, over here. You know, you can touch, there's a lot of books, and they just do touch up inside. And I'm sure that if you're testing this on a real phone and running this on a real phone, there's going to be differences in the touches. But for the purposes of these drills, I think touchdown is going to work. Anyway, so I'm going to press connect. And let me cross-check this, actually, make sure I've got the right one here. IB action, add, button, touched. UI button. Ah, very good. It finally matches it, probably because I made my properties look the same. I'm going to close the little window. My little window doesn't close automatically. Now, if I run it, it should still run. I'm just going to check it real quick here to make sure it did. Build succeeded. I believe I changed the strongs to weak on a couple of them, and I believe I have to go back through and change that. No? Okay. Well, we still don't have any behavior yet, because although we added the items, we haven't set the functionality yet. So now I'm going to come over here and toggle from my viewController.h to my viewController.m. And I'm going to see that I automatically have synthesized. So if you see, we've toggled back to the .h for a moment. And I look at this, I can go, I have property, property, property. And this is where I set the strong, strong, strong. I set that manually, so I'm going to have to make sure if you set it in the little box when you drag it over, it puts it everywhere correctly. If you're too lazy and you don't get it set correctly and you would change it manually, I might have to change it manually. But for each property that's over here, I'm going to have a corresponding synthesize over here. And the synthesize is actually not using any of the memory retention, so I don't even have to worry about the strongs or the weaks. So it doesn't really matter what you put yours on. You can use a strong or a weak or non-pneumatic because it's not here. Otherwise it would have shown up here, which we're not going to use. And I'll talk about memory in another lecture because that's not going to make any sense to you at this point. So what do I have here? I have the .m file where I have the implementation, and I can see on the bottom of the screen I should have something that says IB add button touched, which is good. That's what I wanted to see. So if I go back to my instructions out here, in my view controller, I'm going to open it up. I'm going to add the implementation of the button touch method. And let's try something different. I'm going to double click on the view controller. There we go. Brought the little window up. I'm going to close this guy here, and I'm just going to type this in. But I can do this here. Because the cutting and the pasting isn't really working for me. So let's see. Move this down here. Put this guy on top. Make this guy smaller. So what I did is I double clicked on it so I can actually type it in. So, alright, so this is the IB action touch. So what am I going to do? I'm going to say float. This is actually just like C++. Float number 1, F, which means convert it. It's a strong type, F float. It's equal to number 1 dot text, float value. So it's taking the item that was in the text box number 1, expected at the semi. Did I put a semicolon at the end? Okay, alright, we'll just leave it alone for a second here. Probably, oh, here it is, semicolon at the end. Okay. Float number 2, F. You can put spaces in here, make this a little bit bigger. There we go. So number 2, so basically I'm taking and I'm typecasting number 1 dot text and number 2 dot text to float value. And I'm copying it into a variable that I'm calling float 1, float number 1 at float, number 2 float. So I could do this in 2 separate lines. I can go float number 1f semicolon. Number 1f is equal to number 1 dot text float value, which means run float value, which is a conversion. It's almost like to float, to integer to string on a Java, but this is the conversion for the data type for floats. So number 1 is the name of my number 1f is the name of my variable, number 2f because I'm calling it number 1. Which if I said number 1 here, well, this is my string. I want to make sure I'm not calling it the same as my string name. That way I'm not going to overwrite my string with my float. And then I'm going to go float sum f is going to be equal to number 1f plus number 2f, semicolon. And then I'm going to go self, and we saw this with the first Hello World program actually, self.sum.text, set the text of sum, which is the name of the text box, or excuse me, the label on self, which is the UI, equal to ns string, string with format, which is nothing more than running a method call to format this string to a float. Actually, I just press return here. String with format, and we're going to use the @ symbol because it's a string constant with quotation marks and the $f, which means put it in the float format. If you're familiar with printf, printf and scanf of the C class, it's very similar in concept. except for its part, it's not using the C, it's using the Objective-C implementation of it. It's a string with format. And I'm going to go sum F and then close it off, put a semicolon at the end. And wasn't that much better than cutting and pasting. For me, it worked out actually a little bit better, a little less frustrating. So I'm going to go ahead and save it, and I'm going to close it. And next, we're going to take a look at it here. So first, we synthesize the properties N1, N2, and sum. That's what the synthesize that occurred over here. Let's see. Oops, that was the property, and over here we have the synthesize. Now this should actually show my, yes, this is going to show my changed text in the window here. So synthesizing made it available, initialized it. Next we define the two action methods. So in the add button touched method, we can see the conversion from the string to the number taking place with these two lines here. This is the to a float. Convert this number.text, and this is a float value, which is kind of like a toFloat method. So we get the float value from an string by sending the float values class method to it, and then to obtain the int value we send the init value method. So the float values are then assigned to a local variable within the add float, which is the bottom one, where we said on the bottom, that last line of code, where we said make it an NS string with format of this float f. So take the float value and convert it back to a string and set the text of the sum label to the string that we just created. So the values are added back into the new float variable sum, and the sum is then displayed with the UI label. So the sum with the string with format class method. So the object memory is actually kind of an interesting thing here. Although we moved the memory around, we didn't actually have to get rid of it. So when we use class methods to obtain an object, as with the string with format, when we created it, we actually created a new string object here, and we didn't actually create a reference to it. We didn't use the asterisk to create a reference string. We just said convert it, send NS string, the string with format. And this is going to be a float format, send it back to a string. So we're going to get a string that looks like a float, actually, because it's just going to be the float value converted. So the object will automatically be released. Well, it's going to be automatically released anyway because we have automatic reference counting set. But if we didn't have it on there, we wouldn't actually have to worry about that. So it's because there's no strong reference to the object. Actually, that's why it didn't really matter anyway if we had strong or weak in terms of the reference to that. Which I could have left on weak probably. So the general rule is that if you don't use alloc copy or new, you can get the object with no string reference. You don't actually have to worry about the memory associated with it. It'll automatically garbage collect. So here's our program output. If we run the program, let's see what happens. It will cross our fingers, hopefully run. Comes up, and then we put 2 in the box here. And let's go 4 in the box here, and I click on this, and I get this really small 6.0000. And make this little label a little bit bigger out here. And my number, actually, I figured, I'm going to make it a little bit bigger here. Let's close the simulator for a second here. Try it again. Well, my number is going to be a little bit lower because it's not aligned correctly now. But as we saw actually with another example that I did with Hello World, I think actually we had the small print going on. So now I'm going to go 1 plus 2, and now I got 3.0. I moved it down, so I messed up my GUI. So you should be able to change it as well. 6 and 6 and get 12 out of that. Change this one to 1 and get 7. So it chinks. Whatever it happens to be typed in there, when the button is pressed, it grabs the text, converts it to a float, adds it to the other float, takes the float, converts it to a string, and puts it out on the string as a text attribute to the label. So if you're writing a calculator, I don't know, you're doing some sort of thing that needs calculations, it's just one method that you have to use GUI components to, this is interesting, the cut and paste works. Oh, it's a text. It's actually not taking in numbers. There's no number field, by the way. Everything comes in the form of a text. So the NS string is always created. So Anybody get a working program? Okay.
How can you control the digit, the string, the number of string of the string?
You would have to set the precision on that, which we didn't do. So this is set to the default precision. So on the format down here, I hate to do it, but let's see if this works actually. Oops. I typed in, hold on one second, I'm just going to see if that actually works. But let me just, before I tell you that's how you do it, I put in 0.2 f, which is how it works in printf. And this is a variation of printf. So let's see, 3 and 4, 7.00. So what I did is I typed 0.2 next to the f for the format. So if I did 0.1 as an example, it should do. Yeah, it actually, the object itself is inherited from printf. It's not really inherited, but it's implemented off of printf. So let's see, 4,000 plus 2. There we go, 1. Actually, you have to go here, 2.1. And I'll get the 0.1 in here. So anything that the printf does, so I can put a tab in here. I could put line returns. I mean, obviously, I'm not going to do that for here because I'm converting from a string. I'm converting this number from a float to a string. So I'm not going to put like special characters and stuff in there. Oh, I could. If I wanted to, I could add something to it.
So you could add lots of variables.
And together. Yeah, string them together. And then this, the 0.1 sets the precision for the, you can do that with, well, it works with floats and doubles the same way. You can truncate, you can trim, you can round. You just stick it in the format mask. So if you go online and look at the C format, printf format mask, it uses all the same formatting characters. And that was a sure guess because I've done it in C a lot, but I don't normally do this kind of thing in Objective-C, but it seems to work just fine. So I would assume that would be a good way of doing it. All right, success again. Very good. So now you have 2 working programs. So you can't say you haven't built any programs. And if the values obtained is not quite, well, if we use the values in this particular one, it rounded funny. I put values that wouldn't round. In the example here, if you put in, I think this is 20, I can't read it, it's 25, 25, 25 or something, or 23. Anyway, long story short, if you add them together, or 32.3 is the answer. The precision of the floating point result, so not a defect of your program, it's the floating point mathematics that caused the rounding to be off a little bit, which, you know, obviously, as we see, caused the appearance of that float to be like too long as well. So precision error can be dealt with by other means. Rounding is a desired numeric decimal places is the usual approach. So you can get the correct, round it up, round it down, round it to decimals, or use the floating point formatting mask like we just did a few minutes ago. This is actually going to do a truncate, it's not going to do a floating point. So if it was, gives us the precision. Actually, actually does. The precision mask rounds up or rounds down at the 0.5. So if it was 0.4, it would round it down, get rid of it. So, not quite the same precision as you may not necessarily want, which is the point. Reversing a string. Actually, this next one and then one after that is pretty much the same, is similar. So, in fact, let me see, maybe I want to do the other one first. No, let's do reversing a string. And then we have temperature conversion. So it's basically working with more items. So reversing a string is another way of working with strings. I'm going to close this out because I don't need it anymore. And why do we want to convert? Well, sometimes you want to format some task, some object. It's not included in the methods for the class, and you just want to do something to the string. So instead of converting it, let's say, to a float or to a number, we can just take and use it as a string object. And we can run methods on the string object to reverse it, to compare it with another string, to kind of do a bunch of stuff with it. So in this particular example, we might want to reverse the order of the characters in a string object. Well, we certainly do this in the code. It might be better to add a class method. So this is the one that adds the class method. So we're going to actually add something new to the project. instead of putting it inside of one of the methods, because it doesn't really belong, the functionality that we're doing to reverse a string doesn't normally belong in any of the classes that we're going to use for this project. So we can create a class method to the NS string itself that would reverse any string, so we can use it anywhere we want. And we're going to use what's called a category to add the string reversal method to the NS string. So what's a category? Well, I talked about the categories actually in the Objective-C class if you were in there today. If you weren't, you can go ahead and look at the video. It's a way of using a protocol. So a protocol and a category are pretty much the same thing. A protocol is the formal, category is the informal way of doing it. And what we're going to see is the plus method, the plus for the class level method that's used in a category that takes and creates a generic method, sort of like a function actually. And we can just run the method. So this is just one way of utilizing a category, and I'll show you what that means in a few minutes by going through the example. So once we add the category to the class, all the methods in the category are added to all of the instances of the class of our code, so we don't actually have to add them to any of our existing classes. Since categories are maintained in separate files, it might be a simple matter of including them in any project that we want to use, where we're extending features of the classes that we want to extend. So let's open up another single view project. So I'm going into Xcode. I'm going to create a new project. And I'm going to go single view application. I'm going to go next. I'm going to call this one string reverse. String reverse. And I'm not going to use the storyboard, but I'll use the automatic reference counting. Okay, so I'm going to go next. And I'm going to go create. Oops, it's already there. Let me cancel this for a second. Pick another name. String rev. I know that one's not being used. I don't want to overwrite anything. Let's see. Create. And just as expected, I have a regular single view application, just as the last 3 times I've done this. So hopefully you're getting the impression that it's all done the same way, hopefully, at this point. So I'm going to click on my iPhone because I still haven't changed my device. Just changed my simulator to iPhone. Now I'm working with the iPhone simulator. And take a look at my handy dandy instructions. Add a UI text field and a UI label. So my interface is going to look like that. So I got a picture I can copy now. So I want a text field and a label, because on one of the text fields I'm going to type a string in there. I'm going to take this category that I'm going to create in a few minutes, run a method that's in there, take the string and reverse it around and put it back out onto the UI in this label right here that's empty. Alright, I hate looking at empty labels, so I'm going to leave the word label on mine. Because I'm kind of just like that. So I'll change my background. Alright, I'll change it to gold. That's kind of orangey. I'll change it to orange. Today's all about colored backgrounds. So, don't know why I was in the colored background mode today, but everything's got a background. So let's see, I want a text. I'm going to put the text up here. I could put a little label here that says, enter a string if I wanted to. But I'm just going to create this kind of easy, fun little application, so I don't really need to. So that was a text field. Now I'm going to put a label in here. Where's my label? I'm just going to type in label because I don't see it really easily here. Oh, I could have just scrolled up. Here's the label. So I'll put the label here. I'm going to make the label a little bit bigger. I'm going to leave the label so I can see the label. Let's see if I can make the label bigger. There we go. Label's bigger. I should make the label as big as my text box actually, because it's going to hold the same string. But rather than taking off the word label, I'm just going to leave it on there for testing purposes. That way I can actually see it on there when I go ahead and start dragging and dropping. So. Okay, so got something that sort of looks like that. Real easy interface. In the attribute inspector, set the UI text field return button type to done. Okay, remember before I said, well, if you get the keyboard to go away as you set the return type to done. So in our text field, when we're done typing, because we don't have any buttons on this user interface as we've seen before. So we're going to try and catch a done event. A done means we press return, which means we've returned. So on the return type, and if we go down here on the bottom on the right hand side of the screen, we see return key. On the return key, we're going to set this one to done. A very important step, because otherwise we're not going to get any action. We'll have to put a button up here that says convert. But this example is purposely not doing that because we've seen buttons work all day, so all evening. So we're just trying to get the text to work. So, so on the return of the text, when we're done with that change, we set the return type to done. Okay, good. If you haven't found it over here, it is the fourth icon. 1, 2, 3, 4. It's the one that looks like it. Well, it's called the attribute inspector over here. So it's 1, 2, 3, 4. It's the fourth one over if you can't find it. And it's towards the bottom of the screen here. It's return key, actually. Button type. Return button type to done. Return key is what it should say, actually. I believe it used to be called type in the old days. So your older interface might actually say type instead of key, return key. Okay, so now we're going to do the new thing. We're going to create an Objective-C category. So we're going to go to File, New, File. And instead of creating a class, or in the iOS, I got a iOS touch up here on the top. Make sure you're in the right section. I was just in the macOS section. I was on the Objective-C class, so I got to make sure I'm on the right one every time I create something new. I believe we looked at protocols last time. Protocols and categories are very similar. Protocols are going to create an interface for you that you can include. If you want information on that, go ahead and watch the watch the Objective-C lecture that happened today before this one. And that's more of Objective-C, actually. For iPhone, iPad, it's usually categories that we're going to create. So here we have an Objective-C category. So click on Coca Touch, Objective-C category, Coca Touch, Objective-C category. Go ahead and press Next. We have to give it a name and we have to extend it from something. So we want to make it an object of NSString, because we're going to take a string in from the parameter line, because the string is going to be that text box is going to give us a string. We're going to convert to string. So name, new category, add methods. We're just going to add some generic methods to this project. Make sure that the category is set to NSString. So I'm going to call this add methods. Add methods. Add methods, perfect. Next. And save it anywhere you want. So save it in the project direct folder. Now I have an interesting thing here. In the protocol, when we created a protocol, we just had one file. And it was a .h file, because we were really creating an interface. With a category, it's an informal protocol, which means it's not necessarily attached to any one particular class. Instead, it's a separate unit in its own. It's a generic class that we're going to use, that we're going to put methods in there, and the methods are going to be called from any class without actually having to make an instance of the object. So we have both the .h and the .m file, and we have this thing called NSString.addMethods.h. NSString. Because it's really an object of NSString. So we're implementing here on the implementation NSString. We're calling it add methods, which is the name of our category, which is different syntax than a protocol. If you saw the protocols earlier, NSString. Here's the .h, the interface for it. So we notice that we have two. We have a .h and we have a .n. So click on create. We get these two new files. The naming convention matches the category that we have. So we know it's an NSString. If you have NS object here, you forgot to switch the inheritance to string. So now I'm going to have to type this in. We're going to open up the .h. We're going to create the function prototype for the function or the method that we're going to create. So we're going to open up the .h file. We're going to add the declaration for our new class, and this is going to be an NSString string by reversing string. So I'm going to I've got the prototype, the interface file open, the .h file, and I'm just going to type in here. Oh, what do I got here? I got plus. So all of the other methods that we've seen so far have been using a minus, because we've been creating methods inside of classes, and those were instance methods. So when the instance of the UI view comes up, the UI view controller methods for that particular view are going to be run, and those are the IB actions and the outlets and all the other things all the things that are happening with that, which were all minuses. So we're finally using a plus. The return type is in a string. We're going to return a string. Oops, just press return. And it's going to be a pointer variable because it's an object. All the objects in Objective-C have a pointer next to them, which comes from the dynamically allocated C++, or excuse me, C alloc. So I'm going to call it string by reversing by, if I could spell it right, reversing string. I'm going to do colon. I'm going to take in a string as a parameter. The colon basically says we have a parameter coming in. The parameter is going to be an string, and it's going to be an object, and then we're going to reference it as string, so semicolon. So hopefully you have that typed in. It looks like that. Not take a few minutes, type it in. Maybe I could just cut and paste. No, I'll just type it in. Alright, so in the method, we actually have to create the method. And the method that we're going to create is going to be in the .h file, excuse me, the .m file. So I'm going to double click on this actually. So open up or edit the .m file. I'm going to practice some fast typing here so I don't bore you guys to death. So add the method here after the implementation. So implementation, and we're going to go plus. You know what? Okay, let's just do it this way. Slide number 11. I'm going to try this one more time because I'm destined not to have to type. See how bad this turns out. Oh, it's pretty bad. That's okay. It's actually not as bad as the other one was. Alright, so in my method that I've cut and pasted and I put it in here, I've got two character arrays. One with this C string, which is actually using a C string data type. Because I'm going to take the NS string in, convert it to a C string character array. Look at the maximum length, because I'm going to take it all to the maximum length and loop through and print it in reverse order. That's what I'm going to do to this thing. And I'm going to run a method call on it for string to get the length of the bytes using a built-in C string functionality. And I'm going to use a print. Actually, this is using the native printf. Actually, printf with the $S is for string. Actually, the C string, which works actually on a string. And then here's our for loop for I is equal to 0, I is equal to the string length. I is less than the string length, I++, which is C++ code. And there's an assumption that you're familiar with C. Might be a false assumption. However, if it's not, it's very similar to the same type of construct used in Java. So let's see. Get this guy in here. What do we have? Let's see. Return. And what does this guy say? This guy says expected expression. Okay. And oops, you know why? Because I have the foreign characters here. Let's just do this one here. Alright. Okay. Phew, success. Well, so that was easier than typing it. And I'm going to save it. When I did this, if you're doing the same thing, I had to change the characters here. It came in as the wrong character. So these little single quotes are going to give you a problem if you cut and paste it from the lecture. So will those spaces and the tabs and all the rest of the stuff. I'm going to hopefully there's no extra characters on here either. So I'm going to go ahead and save it. Close the file. Go back to my PowerPoint, which is that was the extent of all of the typing that I would have had to done for this. So you add this method. After you add the method, we'll take a look here. Much easier to index into a C string was what we did actually, and build them from character by character than it would be to use an NS string object. So the code that you just looked at a few minutes ago is using a C string rather than using an array actually. So if I load the file back up, we can actually see it in here. It's using your character array. and treating it like a C string. So we know that Objective-C is built on top of C, so everything that's available in C is also available in Objective-C, which gives us that possibility. Much easier than using an object. This isn't really an object-oriented functionality. This is taking a string and converting it to another string. So this particular method, we set up 2 buffers or character arrays, as we saw before, the original C and then the reverse string. And then we're basically getting the C string representation of the string by using the get C string maximum length encoding method. Get the length of the string, go through a for loop from the back of the string to the front of the string and print it on reverse order. So it must be 1 or more than the number of bytes in the string to account for the null character at the end of the string. We actually put the null character, we change it. We take it from the back and we put it to the front of the string and we'll reverse it. So we copy each character from the string to the reverse, in its reverse order by going character by character through the for loop. After it's done, we put the null character at the end. So we actually recreated the string, and then we copy it back into an NS string at the end. So we're using the same concept as before. Down here we have NS string, string with C string, and then we take this reverse string from the encoding, and then we basically return it. So we're taking the same concept as before, but instead of converting from a float to a string, we're going from a C string to an NS string, which is pretty much the same thing as we did a few minutes ago. So then we return it. So we import the category that we're going to use. In order to use it, we have to import it. So we do an import, and I can type this one actually, in the view controller. So what we do is we just added the code to the NS string add methods category that I created here. So the category's got the .h and got the implementation and specification noting that it's a plus, which means it's a class level method. So now back up in viewController.h, we can take this guy here and say import the category. So I'm just going to type in at the top up here, I'm going to say import quotation marks, NS string. It's the same as there we go, just press return. It's this file sitting over here that we're going to import. So we're importing this in because we're going to use the method. And in order to use the method, we're going to have to essentially import it in. So we have functionality there. Now we have to wire the button. Wire the buttons. Well, we don't have any buttons to wire, do we? We have the property. I should change this because this really isn't buttons. So we have the property for the IB outlet, the UI label, and then we're going to have the input done sender. So we're going to use a UI text field's did end on exit event to wire this in. So let's go ahead and take the property for the we don't have an IB. We have a UI label we're going to treat as the IB outlet. So on the label change. So I'm going to click on the iPhone XIB. Brings up my little window. I'm going to go over here and click on the tuxedo guy so I can get the code next to it. And let me make sure I do this correctly. So I want the property mnemonic IB outlet, the UI label output. Oh, this is the label here. This is the easy one. So I'm clicking on the label and pressing the control button. I'm dragging to the interface. And a UI label, and this is going to be the output. Let me make sure I have those things set correctly. Strong. You know what? When you flip it, it stays on the default. That's why it said weak on me before. It's an IB outlet. So okay, good. It's a UI label, and I'm going to call it output. So good. So I'm going to press connect, and lo and behold, I get the same thing over here. Property, strong mnemonic. It doesn't really matter what order this is in actually. So strong mnemonic, IB outlet, UI label. Okay, good. So now I'm going to take and on the UI text field that's above it, I'm going to right mouse click on it and I'm looking for did end on exit event. So I'm going to right mouse click. We've done this for buttons before, but we're looking for the end, like did the person press return at the end of a text entry. So there's one here that says did end on exit right up here. It's hard to see it, but it's almost like the first event on here. And we see we have, look at this, we have touchdown, we have everything on a button. So these are all the same UI events that occur on buttons actually. That we can put on labels, we can put on text fields. So what we're interested in is the did end event. So I'm going to click on this, press the control button, and come down here and add it. And let me go back here. It's a UI text field, and it's going to be input done. So UI text field. UI text field is the type. Did end on exit is the event. And what was I supposed to call it? I was supposed to call it input done. So I'm going to label this thing input done. And I have the UI text field. Okay, good. And the arguments are sender, and I see sender out here as the argument, so I know this is sender. So I'm going to press OK, or connect. And just double check here and see IB outlet, input done, colon, UI. My wrapping is a little different, but my statement's the same. This is a little note in the bottom to tell you to use the text fields. If you just drag the text field over, you're going to get a property created instead of an action. So we wanted to create the action. All right. Now we have to add the functionality to the button. So if we click on the corresponding viewcontroller.m file, I'm going to close this little window down here, and we scroll all the way to the bottom of the screen. Whoops. Hello. It's down here somewhere. Input done. I had this little guy down here on the bottom. So I could just type that, couldn't I? I'm going to be lazy. Let's see what happens. I'm going to cut and paste here. Copy. Let's see. Actually, I'm going to take this guy here and double click him out here. Do it this way because this seems to work better for me. Add the code in. What's the code we're adding in? Well, let's see. Self-output.text is equal to string reverse. This is the method we're calling. String by reverse string colon sender.text, which means send this output to send the output from that label, excuse me, from the text box. And then nslog self text, well, that's basically printing it to the console, to the log. And it's going to be at the self.output.text, which is the text that appears in that box. And then sender resign first responder, which means take over and flip back control to the view controller from the category method that was running. I'll explain that in a few more minutes, but I cut and pasted and I put it in here and I got new messages, so I'm going to go ahead and save it. While you're doing that, I'll explain a little bit more what that code is actually doing. So this is number 14. Okay, so what happens? So the action method sets the output labels text property to the reverse contents of the input string of the text fields property. Using the string by reversing string method we just added to the NSString class that we created. So it's using a class level method, not from view controller, not from anything. It's using it from that category we put in there. By doing this, the method calls the resign first responder on the sender, which dismisses the keyboard. So remember before I said the keyboard, we can dismiss it, we can put it back, we're going to get rid of the keyboard automatically with this line of code actually that does the this last line of code. There's other ways of getting rid of the keyboard, and I'm going to show you more examples of this as well. But this is just one way of doing it that basically says on the first responder. It means go back to the main view. Forget about what you've been doing so far in terms of the keyboard stuff. So the program output should look like this. It takes a string and reverses it. Let's see if this happens. So I'm going to go ahead and run my project. Cross my fingers. It's always a mystery to see if it's actually going to work. Especially with the cutting and the pasting. Oh, build's successful. It's a good sign so far. Doesn't mean it's going to work. It's a build sign. Good sign. If you get like really weird memory messages over here like I did on the first project, generally means you got some odd characters in there, or something doesn't match, or you've got like two declarations of something. So I'm going to type in, and when I pressed in the button in the text field here, you notice that the keyboard came up automatically. Because I'm using the emulator, I can actually use this keyboard. So I can say this is my string, period. When I press return, it works. And the keyboard goes away. because of the on first responder method call. It said go back to the first. So now I have this is my string. That's what it said. I can't read it backwards. But I do see the dot at the end, so if I go like this and change it like that, now I got the exclamation point at the end. So you can see it's reversed. So we learned a lot about strings tonight. So I think I don't have enough time to start the third project with our next project and can actually finish it in the same session. Let me just make sure. Oh, I have one more slide left on this one, however, before we leave. In terms of a summary of this category concept, categories are a very useful tool for adding functionality to existing classes without actually changing the classes. As an example of this particular case, I could take this category here and add it to any project I wanted to. It's just generic functionality that's this is the class that's holding the functionality that's reversing the string. So I could have like a lot of stuff in here, you know, for a bunch of string manipulations. Maybe you want to convert the strings to floats and then take the floats and add them up, or maybe you want to do different functionalities. You don't have to build them into view controllers or app delegates or anything like that at all. And I can just basically add them to the project, include them in the import, and use the method. So this is kind of like the old days of the including the .h files with all the functions in there. If you remember C programming, when we created .h files, we had structures and functions and all a bunch of stuff in there. And we included the .h so we didn't have to reinvent everything. So you could essentially write functionality that is reusable among many different projects and put them in these category files. Or you can use it once and then toss it. It doesn't necessarily belong to anything else in the project, so I could pull it out and use it into another project. And so when we add the category to class, the child classes of the class will inherit the added methods as well. And as a further exercise, you could try another method to add another method to the NSString category we defined. It replaces the strings, the spaces in the strings with underscores or something else. Or actually you could take and combine it with maybe some methods that does the sum. Because that second, that project we did that took the two strings and converted it to floats and calculated a sum, that's a lot of coding to have to keep redoing. You could stick that in this particular category and then just call sum. Perhaps, or call something else, you know, and just use those method calls. Because what we did was you just added the method call essentially to the class, so that when the action occurred, I just closed the project, but when the action occurs on the action of the ending of the entry of the text into that text box, it just called the method, and then basic method call essentially returned the value. We just took the value and we added it to the text string underneath it, the label. So converted it to an NS string. Actually, the function converted it to an NS string. We took the return and put it on the label. Changed the text on the label to the NS string. All right, so we'll do the temperature next time along with some more projects, but because I can't start temperature and it's too long of a project. But bring your computers and you can write programs, and the more you do this, I think the more you'll learn actually out of it. So. Because eventually, after I've done things 100 times, you're going to go, oh, that's how you do it. I mean, at this point, I hope you guys all know how to populate a canvas full of components and drag them over to the .h files, and then know that you have corresponding .m code that goes with it. Understanding the code, now that's a different story. But all right, we'll leave you with that. See you next week.